Viewers at home, you are welcome to my presentation on the learning curve. Learning curve. This is the part 2 of my lecture on the topic. In part 1, I've examined the overview of learning curve, the general overview of the learning curve, the uses of learning curve, methods of solving learning curve, the determination of learning rate, and examples were provided. In this part 2, I will examine the following. Number 1, meaning of learning curve. I will also consider, or I will also explain the learning curve model and its application. I will explain the learning curve model, and its application. Steps for solving learning curve. Finally, I will provide 2 work examples. 2 work examples shall be provided. If this is your first time of coming across my channel, or if you have not subscribed in the past, please click the red subscribe button and also turn on the notification bell icon so that you don't miss my upcoming videos. If you are a returning subscriber, I say thank you and God bless you. When a team of workers begins a skilled task for the first time, and the task then becomes repetitive, they will probably do the job more quickly as the workers learn the task and so become more efficient as their knowledge and understanding increase. This improvement in efficiency through experience is called the learning effect. Learning curve theory says that whenever a repetitive job is performed, the average time spent in producing a unit falls by a specific percentage whenever the activity level is doubled. That is, if you are repeating the same task, you'll be gaining experience. And when you acquire experience, then you'll be able to perform the job more quickly. Your efficiency on the job will improve. And that process is what we mean by learning. That is learning effect. That's why we say learning curve theory states that when you are performing a job, that is when that job is repetitive, the average time you spend in performing the job will fall by a specific percentage when the activity level is doubled. Then we have the learning curve model. The model of learning curve is y equal to ax raised to power b. Y equals to ax raised to power b, where y equal to average time. When we say average, we mean the time per unit, time for a unit. Average time of a defined cumulative output. Average time of defined cumulative output. Cumulative means you have to sum up. Maybe if the first production will require 400 hours, and the latter one, if the first output is 400 units and the latter output is 300 units, that means the cumulative output is 700 units. The average time of producing this 700 units is y. Since your 700 is your defined cumulative output, the average time of producing a unit out of this 700, that is average time of a defined cumulative output. A, average time of producing the unit in the first batch. Average time of producing a unit in the first batch. To produce one unit in the first batch, how many hours will be required? So that is average time of producing a unit in the first batch. Why X? X is defined cumulative output. Defined cumulative output divided by number of units in the first batch. Defined cumulative output over number of units in the first batch. If the first batch of production is 100 and if the cumulative output is 700, that means the value of X will be 700 over 100, which will give us 7. Y B is logarithm of learning rate. Logarithm of learning rate over log 2. Logarithm of learning rate over log 2. B is the learning factor and it is calculated by dividing the log of learning rate by log 2. So that is the learning curve model. I want to consider the steps for solving learning curve. Steps for solving learning curve. Steps for solving learning curve. The first step is to identify the cumulative output. Identify the cumulative output. Identify the cumulative output. That is the first step. The second step is to estimate the learning rate. The learning rate where this is not given. Where this is not given. In some cases, the learning rate will be given. And where the learning rate is given, that means step 2 is not required. It's only where the learning rate is not provided in the question that you will need to calculate that. And if you watch the part 1 of my presentation on learning curve, then you'll be able to learn how to estimate the learning rate. 2 methods of calculating learning rates were considered in the part 1. Step 3. I told you that this step 1 is to identify the cumulative output, and step 2 is to estimate the learning rate, while step 3 is to determine the average time of defined cumulative output. Calculate the average time of defined cumulative output. That is from the model. That is to calculate the value of y. Calculate the value of y. The value of y from the model are provided. You know, the model is y equal to a x raised to power b. That is to determine the value of y. That is step 3. Calculate the average time of defined cumulative output. That is the value of y. That is the step 3. Step 4 is to determine the total labor hours of defined cumulative output. Calculate the total hours of defined cumulative output. To calculate the total hours, that is to produce the total output, how many hours will be required? To calculate this, total hours will be equal to the value of y. The value of y you have estimated in step 3 times the cumulative output. Cumulative output. Multiply the cumulative output by the value of y obtained from step 3 above. You multiply the cumulative output by the value of y obtained from step 3. Then the last step, step 5, is to determine the time for the additional units. Calculate the labor hours or time for the additional units or incremental output. The additional units, maybe the first production was 400 units and the additional 300 units is to be considered. So the time for these 300 units will be the difference between the total time for the defined cumulative output calculated in step 4, the time calculated in step 4 minus the time for the first 400. So that will give you the time for this additional 300 units. The time calculated in step 4, then minus the time for the first 400 units will give you the time or the labor hours for this incremental units of 300. That is the step for solving learning curve. I therefore want to consider a work example. Example 1. The first unit of a new product is expected to take 100 hours. The first unit takes 100 hours. An 80% learning curve is known to apply. Calculate A. The average time per unit for the first 16 units. B. The average time per unit for the first 25 units. C. The time it takes to make the 20th unit. This question is obtained from HCCA study test by Kaplan. Now the solution. Solution to example 1. Now A, the requirement A, you have to calculate the average time per unit for the first 16 units. I've told you that the formula for calculating the average time of a defined cumulative output, I said it's AX raised to power B. AX raised to power B. Whenever we say cumulative output means the total output from the first unit, that is from 1 to the number of units required. Cumulative output means the total units from 1 to the units required. Now in this question they said the average time per unit for the first 16. First 16 means from 1 to 16. That means the defined cumulative output is 16. Now back to the formula. We said y is the average time of a defined cumulative output. That means if you calculate the value of y, it will give you the time for a unit, that is time to produce a unit in the cumulative output of 16. Now A is the average time of producing the unit in the first batch. Now if you go back to the question, you were told the first unit of a new product is expected to take 100 units. The first unit takes 100 units. The first unit of 100 divided by 1 will still be 100. That means the value of A is 100 hours. X is defined cumulative output over number of units in the first batch. In A, the cumulative output is 16. And the unit in the first batch is 1. That means you will still be having 16. That is the value of X. Then we also need the value of B. B is the logarithm of learning rate. And the learning rate is given to be 80%. And 80% learning curve is known to apply. So our learning rate is 80%. That means we have log of 0.8. If you divide 80 by 100, it will give you 0.8 over log 2. Now let's substitute into this formula. So you'll be having y equal to A, and our A is 100 times X. Our X is 16 into log into b, and our b is log of learning rate, which is log of 0.8 over log 2. Now we have 100 times 16 raised to power log of 0.8 divided by log 2. This will give us 0.4096. If you multiply that by 100 times 100, then you have 40.96. Y equal to 40.96 hours. That is the average time of producing the unit in the first batch. The average time of the defined cumulative output of 16 is 40.96 hours. That is, to produce 1 unit of from the total of 16 units, then it will require 40.96 hours. To produce 1 unit from the total of 16 units, it will take you 40.96 hours to produce that, when the first unit will actually take you 100 hours to produce. Then B, the average time per unit for the first 25 units. The cumulative output in B is 25. The average time of producing a unit from the first 25 units. The formula still remains AX raised to power B. A still remains 100. YX will be 25 over 1. 25. The final cumulative output is 25. Unit in the first batch is 1. That gives us 25. YB is still log of 0.8 over log 2. So now Y will now be equal to A, and our A is 100 times X. X is 25 raised to power B, and our B is log of 0.8 over log 2. So we now have 100 times, if you have 25 raised to power log of 0.8 divided by log 2. That gives us 0.3548. If you multiply that by 100 times 100, then Y will be 35.48 hours. To produce 1 unit from the total of 25 units, it will take you 35.48 hours. And if this seems to be confusing, the formula is Y equal to AX raised to power B. If you evaluate log 0.8 divided by log 2, that gives us minus, that means our B is minus 0.3219. That is the value of B. So back to the formula. The formula is Y equal to AX raised to power B, where A is 100 times X is 25 and B is minus 0.3219. So which is 100 times, if you have 25 raised to power minus 0.3219, that gives us 0.3548. If you multiply that by 100, Y will be 35.48 hours. So if this is the way you prefer to solve it, you may choose this method. This is minus 0.3219. So that is for the B aspect of the question. Now C, the time it takes to make the 20th unit. 20th unit. I didn't say the first 20 units. 20th unit is different from the first 20 units. 20th unit means, if we say the first 20 units, that means from 1 to 20. That is first 20. 20, when you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. From 1 to 20, that is the first 20 units. That means we made from 1 to 20. 20th unit mean the 20 alone. 20 alone. You don't need 1 to 19. 1 to 19 will be removed. That means you only mean 20. That is the 20th unit. Now, the position you need is 20 alone. But to calculate this position of 20, you will need to determine the time for the first 20 units. You will need to first of all calculate the time for the first 20 units. That is from 1 to 20. You will need to calculate this first. Then you now calculate the time for the first 19 units. You know, if you now subtract 19 from 20, the remaining one will be for the 20th position. So that is what we made. Then see now. So y equals to ax raised to power b. We want to calculate the total total average time for the first 20 units. I've told you that this one means from 1 to 20. So that means you apply the formula. Our a still remain 100. Y equals to a, and our a is 100 times x. Our x is 20 divided by 1. That will give us 20 raised to power b, and our b still remain log of 0.8 over log 2, which is 100 times, you have 20 exponential log of 0.8 divided by log 2. Then we have 0.3812. If you multiply that by 100, y will be equal to 100 times this. That will be 38.12 hours. This is the time required to produce a unit from the total output of 20. To produce one, if 20 units is produced, that means to produce only one out of the 20, it will take you 38.12 hours. Now, what will now be the total time required to produce the whole 20 units? Total time required for 20 units. That will be 20 times 38.12. That gives us 38.12 times 20. Then we have 762.40 hours. To produce the total of 20 units, it will take you 762.40 hours. And I've told you that the time required for the 20th unit, you will need to calculate the time for the 19 units as well, the first 19 units, and subtract it from the 20 units to give you the time for the 20th units. If you remove this 13, you have calculated for the whole 20. From 1 to 20 have been calculated. Then, if you now calculate from 1 to 19, and you subtract from 1 to 19 from the 1 to 20, then that means you'll be left with 20th position alone. So, which is the time required in C? Now, let's calculate average time. Average time for the first 19 units. That is time required to produce a unit from the total of 19. The formula still remains y equal to ax raised to power b. Our a is 100, x is 19 divided by 1, since the first unit is 1. The unit in the first batch is 1. 19 divided by 1 will still be 19. Raised to power b. Our b is log of learning rate, and our learning rate is 80%. 0.8 over log 2. We have 100 times, you have 19 exponential log of 0.8 divided by log 2. It gives us 0.3876. If you multiply that by 100, so we have 100, y equal to 100 times 0.3876. That gives us 38.76 hours. That means to make a unit, to produce a unit from the total of 19 units, 38.76 hours will be required. Therefore, what will now be the total time? Total time required for the 19 units. That is for the first 19 units. That will be 38.76 hours times 19. That gives us 38.76 times 19. Then we have 736.44 hours. That means the total of 736.44 hours will be required to produce the first 19 units. Now, you have to calculate the time it takes. You have to calculate the time it takes to make the 20th unit. I'm telling you that 20th, TH, it means the 20th position. The position of 20. Now, the 20th unit now, time required for the 20th unit, which is the time required for the first 20 units minus the time required to make the first 19 units. And the time required for the first 20th unit, for the first 20 units, as calculated above, is 762.40 hours. 762.40 hours minus the time required for the first 19 units, which has been calculated to be 736.44 hours. 736.44 hours. If you find the difference now, you have minus 762.40, then we have 25.96 hours. Therefore, time required for the 20th unit, that is the units that fall within the 20 position, and that is 25.96 hours. 25.96 hours. That is the end of the solution to the example 1. Example 2. A Swiss watch making company wishes to determine the minimum price it should charge a customer for a special order of watches. The customer has requested a quotation for 10 watches, that is one batch, but might subsequently place an order for a further 10. Material costs are $30 per watch. It is estimated that the first batch of 10 watches will take 100 hours to manufacture, and an 80% learning curve is expected to apply. Labor plus variable overheads cost amount to $3 per hour. Setup costs are $1,000 regardless of the number of washes made required. A. What is the minimum price the company should quote for the initial order if there is no guarantee of further orders? B, if the company was then to receive the follow-on order, what would be the minimum price, or what would the minimum price of this order be? C, what will be the minimum price if both orders were placed together? D, having completed the initial order for a total of 20 washes, priced at the minimum levels recommended in A and B, the company thinks that there will be a ready market for this type of wash if it brought the unit selling price down to $45. At this price, what will be the profit on the first 140 mass production washes, that is after the first 20 washes, assuming that marketing cost total $250. This question is also obtained from ACC study test performance management by Kepler. Now the solution. A. Let's look at the requirement A. What is the minimum price the company should quote for the initial order if there is no guarantee of further order? Initial order was the first batch. If you go back to the question, a Swiss watch making company wishes to determine the minimum price it will charge a customer for a special order of washes. The customer has requested a quotation for 10 washes. This is the initial order. If there is no further order now, this is the initial order. At this order of 10, the company is still learning. The company is still learning. So meaning that you bet might subsequently place an order for a further 10. Now, minimum price for the first 10 order, for the initial 10 order, for the initial order of 10, for the initial order of 10. The cost includes material cost of $30. Remember, this is the first production. The first production is in batches of 10. At this level, there has not been an improvement yet in their production system or in their production process. So the application of the learning curve formula or model is not relevant yet to this first production, since this is the first batch that were to be produced. Now, you have the cost, which include material cost. Material cost, which is $30. You were told that material cost is $30 per wash. You know the first order is 10. You have 10 times $30, and that will give us $300 per wash. It is estimated that the first batch of 10 washes will take 100 hours. This is the time for the first batch to manufacture, and an 80% learning curve is expected to apply. Labor plus variable overhead costs amount to $3 per hour. Note the first batch takes 100 hours. The variable overhead cost and labor cost will cost $3 per hour. So we have labor and variable overheads. Note the first batch takes 100 hours. The labor and variable overheads cost $3. So 100 hours times $3, that will also give us 300. Back to the question. Set up costs are $1,000 regardless of the number of washes made. Set up cost. Set up cost is $1,000 regardless of washes made. And what is the minimum price the company should quote for the initial order? The minimum price. When you sum up this, you have the total relevant cost to be 1,600. So, and now what is the minimum price? Minimum price the company should charge for the initial order of 10. We have 1,600 divided by that 10, which is the quantity ordered, and that will give us 160 naira, $160 per wash. $160 per wash. That is the solution to the A aspect of the question. Now the B aspect. If the company was then to receive the follow-on order, what will be the minimum price of this order? Note the first batch is 10 and the follow-on order is another 10. Now, I've told you that the first step is to identify the defined cumulative output. Defined cumulative output. I told you that cumulative output is the units from 1 to the last units required. Note the first batch was 10 washes, and the latter one is also another 10, which is the follow-on order they are referring to, the further of 10. That means you have the 10 for the initial plus the latter one, which is also 10. So that means you have 20 washes altogether. When you have the total of 20 washes, this is the cumulative output, and you were told that if the company was then to receive the follow-on order, what will be the minimum price of this order? At this further production of 10, there will be an improvement in their production system. So a learning curve process will be applied. And I've told you that the average time of a defined cumulative output is given by this formula. And the defined cumulative output is given to be 20 washes. And you want to calculate the time of producing the unit from this 20. And if Y is this, and what is the value of A? And I've told you that A is the average time of producing the unit in the first batch. Average time of producing the unit in the first batch. Now back to the question. The first batch, the customer has requested a quotation of 10 washes as is one batch, but might subsequently place an order for that 10. The units in the first batch is 10 washes. Now, we were told that how many hours will these 10 washes take? Material costs are $30 per watch. It is estimated that the first batch of 10 washes will take 100 hours. This is the total time required to produce that 10 units, that is 10 units, which is one batch, the first batch of 10. Now, that means A, since it takes that 10 washes take 100 hours. 10 washes is 100 hours. Therefore, one watch from the first batch of 10 will take 100 hours divided by 10, and that will give us 10 hours. Then S is defined cumulative output, and our defined cumulative output is 20 washes. 20 washes over number of units in the first batch, and the number of units in the first batch is also 10. So we have 20 divided by 10. That will give us 2 washes. Then, and I've told you that B is the logarithm of learning rate over log 2. And if you go back to the question, the learning rate manufacture and an 80% learning curve is expected to apply. Therefore, our learning rate is 80%. So we have log of 0.8 over log 2. Log of learning rate over log 2. That is B. And if B is log of learning rate over log 2, therefore, our y now will be equals to A, and our A is 10 times x, and our x is 2 raised to power B, and our B is log of learning rate, which is log 0.8 over log 2. Now 2 exponential log of 0.8 divided by log of 2. That gives us 0.8. So we have 10 times 0.8. Therefore, y equals to, if you multiply that, you have y equal to 8. That means to produce 1 unit from the cumulative output of 20, to produce 1 from these 20 units, from the first 20 units, or for the first 20 washes, to produce 1 will require 8 hours. Now back to the requirement. If the company was then to receive the follow-on order, what will be the minimum price of this order? Of this order B? The follow-on order is the order of further 10. You know, the first order was 10. The follow-on, the other one that will be placed later, is also another 10. Further 10. That is the follow-on order. If they are to receive a follow-on order, what will be the minimum price? Now, remember, the first, now what will now be the total time for this 20 now? 20 washes, total time required, total time for 20 washes. No, the cumulative output is 20 washes. What will that be the total time for that? So we have 20 times 8, and that will give us 160 hours. So the cumulative output of 20 will require, or will take you 160 hours. But remember, the first output, the first 10, the first batch of 10 takes you 100 hours. First batch of 10 takes 100 hours. That means the follow-on order of 10 will require, or will take you 60 hours to produce. In the B aspect of the question, we were told that if the company was then to receive the follow-on order, what would the minimum price of this order be? Remember, the follow-on order is an order of further 10 washes. You know, the first batches was 10. The follow-on order will be another 10. So now the minimum price now for that 10, minimum price for the follow-on order of 10 washes. So we have materials. The material cost still remain $30. Material costs are $30. So we have 30 times the follow-on order of 10. 30 times follow-on order of 10 washes. That will give us 300. We have labor and variable overheads. Variable overheads. Now, labor plus variable overhead costs amount to $3 per hour. No, to produce the follow-on order of 10, additional 60 hours will be required. 60 hours will be required to produce the follow-on order of 10. So we have 60 hours times $3, and that will give us 1 80. We were told that there is a setup cost. Setup costs are $1,000 regardless of the number of washes made. You know, the first batch of 10, the setup cost will be incurred. Setup cost of $1,000 will be incurred. We were told regardless of washes made. You know, the total washes that will be made in this B aspect of the question will be 20 altogether. Since the setup cost has been incurred on the first batches of 10, that means the setup cost will not be incurred in further production of another 10. Since we were told that the setup cost of 1,000 will be incurred regardless of washes made, so there will be no setup cost on the following order. So we have the relevant cost to be $480. So minimum price per wash now will be $480 divided by 10. That gives us $48 per wash. So that is the answer to the B. Finally, we also have C. What will be the minimum price if both orders were placed together? See now, if both orders were placed together, minimum price if both orders were placed together. No, both orders amounted to 20 washes altogether. So that means material cost will be 20 washes times material price of $30 per wash. 20 times 30, that will give us $600. Labor plus variable overheads. No, 160 hours will be required for 20 washes altogether. So 160 hours will be required. So we have 160 hours for 20 washes times the labor rate is given to be $3 per wash. The rate is $3. So 160 times 3, that will give us $480. We also have setup costs at 1,000 regardless of the number of washes made. We have setup cost. Setup cost will be considered in this case because the first batch of 10 is included in this 20. That means from 1 to 20 is what we are considering. So the setup cost of 1,000 will be considered. So the total relevant cost will be, when you sum it up, $2,080. So minimum price now. Minimum price will be 2,080 divided by 20, and that will give us $104 per wash. $104 per wash. That is the requirement C. Now D. Having completed the initial order for a total of 20 washes, price at the minimum levels recommended in A and B, the company thinks that there will be a ready market for this type of watch if it brought the unit selling price down to $45. At this price, what will be the profit on the first 140 mass production washes? That is after the first 20 washes, assuming that the marketing cost totaled $250. Now the solution. Remember, define cumulative output now will be defined cumulative output. You know, further order of 140 after the first 20. So we have 20 plus 140, and that will give us 160 washes. Now, our formula remains y equal to ax raised to power b, where a is the average time of producing the unit in the first batch. Remember, the first batch is 10 units, and that's require 10 hours. 10 hours divided by 10 units, giving us 10 hours per unit as determined earlier. S is defined cumulative output, and our cumulative output still remain 160 units over number of units in the first batch, which is still 10 units, and that gives us 16 units. Then our B still remain the log of learning rate over log 2, and our learning rate is 80%. So substituting into the formula, we have y equals to a, and our a is 10 hours, times our x, which is 16 units, raised to power log of learning rate, which is 0.8 over log 2, and which will be 10 hours, times, now when we have 16 exponential, if we have 16 exponential, the log of 0.8 divided by log 2, that gives us 0.4096. If you multiply that by 10, so our y will be times 10, y will be 4.096 hours. That means to produce 1 unit from the 160 units altogether, it will require 4.096 hours. So total time or hours required for the whole 160 units, or washes rather, 160 washes will be 160 times 4.096 hours. That gives us 655.36 hours. If 160 takes these hours now, and the first 20 units take 160 hours, remember you were to consider the 140 after the first 20 washes. So first 160 units take, as calculated, 655.36 hours. 655.36 hours. First 20 units, alright, is washes. First 20 washes take 160 hours as calculated. 160 hours. If you subtract 160 hours from 655.36, that means extra 140 units will require 495.36 hours. That is additional or incremental, that is extra 140. Additional 140 washes requires 495.36 hours. Now back to the question. You were told that having completed the initial order for a total of 20 washes priced at the minimum levels recommended in A and B, the company thinks that there will be a ready market. There will be a ready market for these type of watch if he brought the unit selling price down to 45. Now they want to bring the unit selling price down to 45. At this price, what will be the profit on the first 140 mass production watches? Now you want to determine the profit on the 140 mass production. You want to prepare the profit statement. Profit statement. Profit statement after for 140 watches. Profit statement for 140 watches after the first 20 watches have been produced. The first item should be your revenue. Your revenue will be the output, which is 140, or number of units sold times the selling price. And we were told that the selling price is given to be $45. So we have 140 times $45. 140 watches. 140 watches times $45 per watch. And that will give us 140 times 45. We have 6,300. From the revenue with less cost, with less total cost. The total cost includes material cost. Material cost incurred on 140 watches times the material cost per watch is $30 as given, times 30. $30 per watch. We have 140 times 30. We have 4,200. 4,200 dollars. Then we also have labor plus variable overheads, and the number of hours required for the additional 140 watches is 495.36. 495.36 hours times, you were given the labor rate per hour. Labor plus variable overhead cost amount to $3 per hour. So we have times $3. So if you have 495.36, 495.36 times 3, that will give us 486.08. Then the setup cost of $1,000 will not be considered because it has been used in the initial production of the 20 units. No, the 140 units is considered after the first production of 20 units. So this setup cost would relate to the first production or initial production of 20 units. So we are not going to consider it in this very one, in additional or other. For this type of watch, if it brought the unit selling price down to $45, at this price, what will be the profit on the first 140 mass production watches, that is after the first 20 watches, assuming the marketing cost total $250. So we need the marketing cost of $250. So marketing cost, and that is given to be $250. So when you sum up the cost, so we have 4,200 plus 1,486 plus 250. The total cost is $5,936. So if you subtract the total cost from revenue of 6,300, then you have the profit of $364. So that is our profit. That is the solution to the example 2. So this marks the end of the part 2 of my lecture, series on learning curve. Part 2, in part 3, further work examples shall be considered. Or I will also consider where the learning process will stop along the line, and the time that will be required for further production after the learning process has stopped will be at a steady rate or constant rate. I will consider that in part 3 of my lectures on learning curve. Thanks for watching. Please don't forget to like, share and subscribe.